TV. Today we'd like to present to you our Chemistry 1 demo. This is the first installment of our Chemistry demo series and is geared towards 1st through 3rd grade students. Teachers, you will find that many of these activities are going to match your science standards. For some, chemistry is a scary word. This lesson may take some adjustment for younger students, but we provide you with everything needed to make chemistry fun and accessible to you and your classroom. If this demo is selected for Wow on Wheels, we even offer training for the teacher.
Now this lesson is all about polymers, how diverse they are, and how we come across them in nearly every aspect of our lives. Different polymers have different properties. Some are stiff, some are flexible, and some are even in liquid form. Chemists can make polymers for a variety of applications.
Teachers, we begin the lesson by telling the students that we will be talking about a special kind of science called chemistry, and that today they'll be learning some new science words. Chemistry is the part of science that studies what everything is made of and how it works. Cooking is a form of chemistry, so is making ice cubes. Medicine is the result of chemistry, so is paint. Chemistry is all around us. We'll also ask the students if they've ever heard the science word matter. Matter is everything around us. Objects that take up space and have mass are called matter. Everything around you is made of matter. Chocolate cake is made of matter. Your desk is made of matter. You are made of matter. And all these things, these pieces of matter, are made of atoms.
Now our first wizard or teacher demonstration introduces two more chemistry words, monomer and polymer. A monomer is a single atom or molecule. Think of it as one paper clip. We can link a bunch of monomers together, like this, in order to form a chain. In chemistry, we call this chain a polymer. Think of it as a monomer unit holding hands in order to form a chain. For the younger students, you could even have volunteers come up and demonstrate this. You actually use polymers every single day. Plastics are made of polymers. Some of their toys are made of polymers. You likely even have a polymer in your fridge at home.
Teachers, at this point, ask your students to find some things in the classroom that are made of plastic.
Our bodies make polymers called proteins. Just like some of the polymers we've seen around the room, polymers do different jobs in our bodies. For example, our hair, our fingernails, even our saliva is made of polymers called proteins.
When beginning our first student activity, tell the students that they will build a polymer together. We're going to use these beads and a pipe cleaner. We will pretend our beads are a monomer unit, just like the one paper clip, and we will string them together to make a polymer. Students will then have a bracelet to put on and take home.
Now some polymers can be linked together in order to alter their properties further. We will show this idea of cross-linking by showing a sample of pipe cleaners that have been tied together. The white pipe cleaners are our polymer chains. When we add a certain chemical, it causes them to link or be tied together. This is represented by our yellow ones. Now when the strands are stuck together in this way, the matter changes from a liquid to a more solid type form.
Explain to the students that they're now going to perform this chemical reaction and transform a liquid polymer into a solid. Review the states of matter with them, solid, liquid, and gas, and review that energy is needed to change a state that the matter is in. Teachers, once the students receive their baggie, make sure they know not to open it.
Now in student activity 1, the students will line up and come up one by one to get their polymer. You and the wizard will add 2 solutions to each baggie. Now, if time permits, you may also add 1 drop of food coloring just to give it a little bit more color. Once all the ingredients are added, you want to very tightly seal this bag up before handing it to the student. They should then return to their seats in order to knead and shake the bag. They will notice that very quickly the ingredients will start to congeal into their more solid form. You want to reiterate the idea of chemists designing a polymer to serve a specific purpose. Structure equals function. This is why we have so many different types of plastic items.
begin our second wizard demonstration, tell students you will show them another example of polymers, just like the slime they made, being designed to do a job. Ask students what a diaper is used for. Then ask students if they can explain how it might work. It's actually a little different than what they think. Let's show them.
Now, using our deconstructed diaper, show all the pieces. The outside of the diaper is made of a polymer. The adhesive used is also another type of a polymer. Even the padding is a polymer. Now, ask them what they think is actually absorbing the liquid. Most will probably guess that it's the padding. We can use a cotton ball to demonstrate how poorly this padding actually holds water. It's not doing a very good job.
Explain to the students that there is a specific polymer or kind of plastic in the padding that is used to absorb liquids. Show them the baggie of the water-absorbing powder and tell the students that this is the only part of the diaper that they actually need to do the job. Let's have them estimate how much water it might be able to hold. We're going to pour about 4 to 8 ounces of water in our baggie of powder. We're going to let it absorb. We're going to let them notice what's happening. Let's pour in a little bit more. Let's just see how much water this powder can absorb.
We then set the bag aside and tell the students that we'll look at it again during the conclusion of our demonstration to determine exactly how much water was absorbed. We begin the third wizard demonstration by explaining to students that even if we have the same materials, how they are prepared changes how they look and feel. The same type of plastic can do a different job. Ask the students if they know what this is. Do they know what these are? We can then tell them that both the CD case and the packing peanuts are made of the same type of polymer or plastic. It's called polystyrene.
Then we will show the students 2 different tubes. Explain to the students that the same materials behave differently depending on how the plastic is prepared. If there's time, you can even pass these around and let the students examine them. Tell the students that it is the same material, but the chemists prepared these plastics in a different way. And as you can see, one floats and one sinks.
Now, the peanuts are made by blowing the plastic full of air, kind of like someone would make cotton candy. This means that there's more air between those polymer strands, making them lighter in water. In its more solid form, there's less space between those polymer chains. When it's packed together like this, the polymer sinks.
In our last activity, place an empty flask on your tray. Pour a small amount, about 100 to 150 milliliters of acetone, into the jar. Explain to the students that this is a liquid that is used in chemistry that breaks plastics apart.
It is also used at lower concentrations in order to remove nail polish, which is also a polymer. Now, if time permits, you can ask a volunteer student to assist you. In this case, when handling this liquid, we need to protect our eyes. So both of you should put on your safety glasses. Ask the students to hypothesize or predict what will happen to this peanut when it's dropped in our chemistry fluid. Have your students drop one in. Show the class that the peanut dissolved. You can even have other volunteers put in other chunks, time permitting.
When it's time to wrap up the chemistry demo, return to the diaper demo and show how the powder has gelled up.
Review that polymers are all around us, from the utensils that we use to bags, even diapers, even on airplanes and rocket ships. They're designed to do different jobs, and we've seen that the same material can even do different things. Do a quick review then with some follow-up questions for discussion. What is a polymer? How can chemists change them?
Teachers, this chemistry demo is best used with students in 1st through 3rd grade and will meet some of your science standards. Check out our website for other chemistry demos for your older students. Thanks.